The force of the wind blowing on a vertical surface varies jointly as the area of the surface and the square of the velocity. If a wind blowing at 40 miles per hour exerts a force of 50 pounds on a surface of 500 square feet, how much force will a wind of 80 miles per hour place on a surface of 2 square feet? The first thing that we'll do is define our variables. We're going to use F to represent the force of the wind. We'll let A be the surface area of the vertical surface, and we'll let V represent the velocity of the wind. We were told that the force varies jointly as the area of the surface and the square of the velocity. And thus, we know that F is equal to the constant of variation K times A times the square of V. We're also told that a wind blowing at 40 miles per hour exerts a force of 50 pounds on a surface of 500 square feet. So we can solve for the constant of variation, K, by substituting these values into the general formula, F equals KAV squared. We have the force of 50 is equal to K times the area of 500 times 40 squared. 40 squared is 1600, so we have 50 is equal to K times 500 times 1600. Multiplying on the right side, we have 50 is equal to 800,000 K. And dividing both sides by 800,000, we have K is equal to 1 over 16,000. So we have K is equal to 1 over 16,000. So now our equation of variation is F is equal to 1 over 16,000 times A times V squared, or AV squared divided by 16,000. Now we're ready to find how much force a wind of 80 miles per hour will place on a surface of 2 square feet. To find that, we substitute for A and V in the equation. So we have F is equal to 2 times 80 squared divided by 16,000. 80 squared is 6,400 times 2 is 12,800. So we have F is equal to 12,800 divided by 16,000, which is equal to 0.8. And thus, a wind with a velocity of 80 miles per hour blowing on a surface that is 2 square feet will exert a force of 0.8 pounds.